I'll start by proving that 0 equals 1. Suppose x equals 0. If you then divide both sides by x, you get x over x equals 0 over x. Now think about this. Any number divided by itself equals 1. 2 over 2, 3 over 3, 12 over 12. 0 divided by any number equals 0. 0 over 1, 0 over 5, 0 over 100. Therefore, 1 equals 0. Neat, huh? Fortunately, this doesn't mean that all of mathematics and our universe is broken. If you look here, you'll see that x equals 0. So if we divide by x, we're dividing by 0. When you learn about fractions and division, there's one important rule you learn. You cannot divide by 0. But it's always just repeated as if we came up with it, when in fact we didn't. There are many reasons for it, such as this proof above. Okay, let's look at this in the simplest possible way. Imagine you're throwing a party. You've got 6 sweets and want to give 2 to each guest that comes. How many guests should come so that each one gets exactly 2 sweets? The answer, of course, is 3, which is 6 divided by 2. What's important to note here is that 6 over 3 equals 2 and 6 over 2 equals 3, which you can easily show algebraically, like this. It's a useful trick. Now, what if you have, say, 10 sweets, and you want to give them out equally to everyone coming, so that everyone got exactly 0 sweets, and you'd have nothing left over at the end? It's impossible. No matter how many times you subtract 0, you will still have 10 left over. Therefore, 1 divided by 0 is what we call undefined. Well, what about 0 divided by 0? Well, that's exactly what we did in the first example, and showed that 1 equals 0. This makes sense if you consider the question, if you have 0 sweets and want to give all guests 0 sweets, how many guests do you need? Well, 0 works, 1 works, 100 works, any real or complex number works. After all, any number times 0 equals 0, so 0 divided by 0 can be anything. In fact, we can make 0 divided by 0 equal anything at all if you graph the right function. If you use 0 over x, we get the result 0. If we use x over x, you get 1. If we use 2x over x, you get 2. There's a neat little algebraic equation we can use to summarize these two rules. Suppose a and b are two numbers such that a equals b divided by 0. Now multiply both sides by 0. We get the equation b equals 0. Therefore, the only number we can divide by 0 is 0 itself, and that value it gives can be anything at all. We can write these two rules in fancy set notation as well, like this. But wait, you might be asking, isn't 1 over 0 infinity? Well, in some ways it is, but you can't say that 1 over 0 equals infinity, because infinity is not a number, it's a concept. It's as if you said that 3 plus 3 equals big, or 6 times 2 equals red. However, you can use this symbol in maths. You just can't say that anything is equal to it. Instead, you use limits. A limit is basically what a function approaches, but never quite reaches. For example, the limit of 1 over n, as n approaches 0, is infinity, but 1 over 0 does not equal infinity. Nothing can. There's one more crucial distinction to make, and that is between positive and negative infinity. If you look at the graph of y equals 1 over x, you'll see that it goes to positive infinity from one side and negative infinity from the other. So we put in a little plus or minus to indicate from which direction we're approaching 0. Now here's a final little question involving limits. What's the limit as n approaches positive infinity of n plus 1 squared divided by n squared? We can solve this by splitting the numerator into 3 terms, n squared plus 2n plus 1. Now we can split the fraction into 3, n squared over n squared equals 1, and we can simplify 2n over n squared to 2 over n. Now think about this. As n approaches infinity, what number does 1 over n approach? The answer is 0. Therefore, the limit of any fraction with n in the denominator as n approaches infinity is 0. So the limit we are calculating is 1 plus 0 plus 0, which is 1. And in fact, if you graph this function, you can see it gets closer and closer to 1. So that's how you can harness the impossibility of division by 0 in the form of limits.